So let's build our simulation. So I'm just going to turn off this visualizer and that one, and come here and go into and grab a dot network. Now in the previous week we made one in SOPs with the new Pyro, not SOP solver, but the SOP context solver. So you can use that, or you can use a DOP network out here, or you can even use a DOP network in here as well. Really, you get more control definitely with creating your own DOP network. The solver in the SOP context is more for convenience, really. But you can do it either way. You can do a lot. The solver is great. There's a lot you can do there and get some great sims coming out really quick, as you can see as the result of our previous week's work. But we're going to do it in this way as well, and it's good to know both ways. So let's dive in here, and the first thing to grab is our Pyro solver sparse. Okay, make sure you grab this one, and a Pyro smoke object, excuse me, I always make that mistake. Smoke object sparse. Okay, so they are two different nodes to the original Pyro solver and the smoke object. Okay, so make sure you don't mix and match. So connect them up. Obviously we also need a source, so we want the smoke. Smoke now. We need a volume source. Okay, and that will, the order of these is kind of changed around as well. So there's your forces, whereas the other Pyro solver, I think it's so you have velocity there, you have advection, and then your sourcing at the end, whereas now we've got forces there, so you're going to connect your microsolvers there, sourcing here, and advection there. So we are going, I've already forgotten, into this part. Okay, get rid of that. And let's grab our source. So we're going into the SOP context. Let's go and find the outs that we made. That's in source, out source. Just notice I'm going to give this a better name as well. FireSim. Okay. So yeah, we need two things here. So we could use we don't need a transform, so we need two operations. Okay, so we're bringing in the burn that we created, and that's going to be, so that's the source volume, whichever the source volume is, whatever you created in the source, that's the name of it, is burn. That's just the general workflow that you'll find with the shelf tools. The name could be anything, to be honest, but what's important is that the target field is flame and nothing else, right? So wherever you want fire to be, this is where the solver will create flames, basically. Okay, using this. So this is what we generated, and we're telling the solver make flames in this area. Okay, and I'm going to set that to, so we have different operations here. Adding is by default. I'm going to set it to maximum, so the highest value, either my source or what's already there, will be taken. Okay, so that's okay. And then I'm also going to set a temperature. So the temperature is the one that we created in the SOP context, and the target field within this, in here, is also called temperature. Okay, so that makes it a bit easier. So for this one, we're going to set it to pull. Okay, and I think we spoke about it last in the previous week briefly. So basically, I'm going to set this to 0. We've got an acceleration strength and a deceleration strength. So basically, we're going to try and move the values that are within the solver towards the values that we've got in here, okay, into the source, and we're going to move them with this strength, and a strength of 50. So they're trying to, if the temperature is lower than 1, than basically what we've got coming in, then they'll be moved towards that, okay, not just set, you know, straight with, which is what this will do. Okay. You know, they're just different things. You can play around with them and experiment yourself to see the different results. I tend to always check this as well, enlarge fields to contain sources. So, you know, as we discussed with sparse solving, with sparse simulations, we have an active region, and if the source coming in is far away from that active region, if we maybe simulate one frame, you can see we're kind of getting something. We're not going to see anything because of the visualizer, but that's what's actually being simulated. If I go to smooth shaded, that we can see it a bit better. So inside these blue boxes is what's actually being simulated. And if in the next frame my source is kind of out here somewhere, then, you know, it could be either clipped off, or, you know, this will struggle to kind of stretch to find it. So checking this will will guarantee that these active region will capture that source, you know, before the next substep. Okay, so set that back. So that's good to go. Now back into the smoke object, we want to set up a size. So I'm gonna definitely excuse me, treat y as close below 0. So that essentially gives us a ground plane. Okay. We're in a room on the floor, so that's fine. There's no holes in the floor. We'll just set that to 0. And now for the scale, if we go back into our camera, we can set up a max size. Even though it's sparse, you know, that doesn't mean that flames can travel way out of our field of view and you know, be a waste of simulation time. So I am going to set a max size, and we can do that using, if I turn this off, this domain that will show us that, and maybe something that can help. If I turn on this corridor, come inside here, and then set this to ghost other objects, there we can see that. That's one actual benefit of working in DOPs. Having a DOP network here in the OBJ context is that I can do that. So if I'm in a SOP context, maybe I can just show you here. If I go into DOP now, if I create a DOP network here, I think, yeah, see, we won't see that. Okay, we don't see the geometries. Even if I show all objects, whether it's out here or out here, I can't see it. So it's just for, you know, doing things like this, but it can be handy, surprisingly often, to see what else you've got. So yeah, unfortunately we can't just kind of draw that, so we just use these values here. So I'm going to move it over back a little bit. Okay, spacebar and H. Maybe we could look at the source actually, because I think that's maybe a bit more important. If we look at this, turn that on, turn that off. No, I want to see after we deleted it. This part. There we go. Great. Okay. So I'm going to kind of put my box around this box, basically. Okay. So I'm going to move it back a little bit, move it up, give it a bit of height, right? And move it down 8.2. Okay. So that way it should clip the top of the of our view. So I'm kind of doing it. If you see there, none of our smoke is going to or flames are going to hit the roof, because we'd be able to see that, the collision with the roof. Okay, or see it disappearing also. 6.5 here, so that's going to narrow it. Okay, we do have holes, so we got, you know, we're going to have smoke and fire going through the doors, but you can see that I'm not going to be able to see the edge of the boundaries through the doors here from this camera, right? And let's make it a bit longer so that we got some depth going back this way. Okay, so that's good for our container, basically. And for our source, we've got them coming in as well. Before I go, set up the visualizer. Okay, so it's not set up by default. We turn that off and turn the domain off, turn on the active region, multi-field. And I'm going to turn that off as well, and then go into the multi-field here, and then our density field will be density. Okay, density scale is 1 at the moment. You can play around with that, but I'm going to just leave that as it is, I think. Diffuse, we'll set that to density as well. And then the emission will be flame. And the colors, I'm going to use the temperature. Okay. And we'll come back and play with these values. You know, we'll give it some scale. Actually, I'll just do that now. Set that to 1, and that should allow us to see something. There we go. So obviously it's very low resolution, but that is, you know, a very poor quality, but it is a simulation that is actually working. Next we need to come in and dial these values, and later also we'll add in some microsolvers as well.